Here we are at example 10 from our 0.4 set of notes. We're asked to solve for x. Now we first have to identify where that is, and we notice that it is down here on the bottom. Well, there are a variety of ways that we can continue with this, but kind of the mainstream one is to stick with that LCM, okay? We do have fractions here. Fractions are no fun, so we're going to go ahead and multiply both sides by the LCM. Now looking at this, we don't really have to worry about the left side because, well, it's not a fraction. But the right side, we notice that the whole thing on the right side is one big fraction. When we look at the denominators, though, we notice it's that this entire thing, c minus x. So that actually ends up coming out to be our LCM, c minus x. It looks like a weird least common multiple, but that actually is our least common multiple in this particular case. You know, it's not like it's just necessarily one item or one number. Maybe it's an entire set on the bottom. Now, when we go ahead and multiply both sides by the least common multiple, we have our c minus x that we're multiplying on the left side. We're also doing that for the right side. Again, these are being multiplied. Now, on the left side, we'll go ahead and just leave it the way it is. So we just have our c minus x times g equals. You could go ahead and distribute the g. You know, you can. In fact, maybe in a little bit we might. But for right now, we can go ahead and just leave it the way it is. Because really our end game is to try and get x all by himself. Now on the right side, we have d minus r on top. You don't have to throw the parentheses, you can. But on the bottom, we have c minus x, and on top we have a c minus x, and we're multiplying these two. Then those two will actually end up dropping out with one another. To kind of give you an analogy with that, that's like saying 4 over 5, the 4 representing this d minus r, the 5 representing this c minus x, and what we've done is we've multiplied both sides by the least common multiple. In this case, it was the whole bottom 5. So the 5s end up canceling out with one another. Okay, as we see, 1 on top cancels out with 1 on bottom. The whole c minus x. Now, there are a variety of ways that we can continue. Okay, so what I'm going to go ahead and do is kind of create a split so you can see both versions. Previously I had said you can go ahead and distribute. In this case, we'll show what it looks like if you use the distributing method. If we went ahead and distributed, we'd have g times c, or cg, and then negative x times positive g. Well, that would give us negative xg. The right side doesn't really change at all. It's still d minus r. Again, you can have that in parentheses. You don't have to. Well, our end game is still the same. We're still trying to get x, not negative x, but x all by himself. This cg has really nothing to do with x. So what we can go ahead and do is subtract that from both sides. On the left side, they'll end up canceling out with one another, leaving us with negative xg equals, on the right side we end up with d minus r minus c times g. Again, all we did there in the green step to the orange was subtract the cg from both sides, because it had nothing to do with x. Now lastly, we want x all by himself. Well, there's this negative that's giving us an issue, really negative 1, and also this g that's giving us the issue. And what we can go ahead and do is divide, because it's stuck and glued to x, by negative 1g on both sides. Again, we really just care about the x. The negative 1 and the g are stuck and glued to x. They're kind of acting as like the coefficient number that we normally divide at the end. And when we do that, we end up with the negative 1 canceling out with the negative 1, the g canceling out with the g, leaving us with just the x variable that we want, equals this whole thing, d minus r minus cg all over negative 1g. So pretty much x came out to be equal to this right here. So that's the distributing method, okay? And it's a perfectly good method. If you honestly write this on a test of mine, I would absolutely accept that. Now let's look at the other method. If we have c minus x times g equals d minus r. So in the previous version, we went ahead and distributed. In this version, we're going to go ahead and divide by our coefficient. Now what we mean by that is we have this c minus x. It is together in a set of parentheses because earlier we multiplied it by the LCM. The whole left side was multiplied by c minus 6. And that's still being multiplied now by this g. Well, we can compare this g as kind of like a coefficient. So if this was our variable x and g was like some number, let's say 5, well, that would be the same thing as saying 5x. What we can go ahead and do is divide both sides by that coefficient. So in this case, we would divide both sides by g. Now when we do that, on the left side, the g's end up canceling, leaving us our c minus x. On the right side, we pretty much just have this, the d minus r, all on top over g. Well, our end game is to get x still all by himself. Right now it's not. We still have a c, and we still have a negative 1 in front of it. There are a variety of ways that we could proceed, but pretty much, I mean, you'd probably subtract c from both sides, but again, there's a variety of ways that we can continue on. I'm just showing us some of the more mainstream ones. When we do that, we end up with negative 1x equals d minus r all over g minus c. It's not part of the fraction. This negative c is not part of our d minus r over g. It's not. And then lastly, to get x all by himself, we divide by negative 1 or multiply both sides by negative 1. It's the same thing. We'll go ahead and multiply both sides instead by negative 1. Negative 1 times a negative 1 gives us a positive 1. So then x is all by himself equals d minus r all over g minus c, and all of that times negative 1. Now, believe it or not, there are a variety of even more ways to represent this, but by and large, guys, we try and advocate a little bit more for the distributing. The reason why is in some of your later math, that's actually a pretty handy tool to know how to distribute, but there are a variety of other ways to do it as well, okay? So I don't want to discourage any one method. Again, though, that is example 10 from our 0.4 set of notes.